Welcome. You can make a small note. Today we are starting T sections. T sections including inverted also. Inverted also. First I will cover all this one. Title you can see it. Okay, start. Question number 9. Find moment of inertia about center order axis. I told repeatedly center order axis means you have to write. See, already told earlier, center order axis means a horizontal and vertical axis pass into centroid. You write all those statements. First you have to locate centroid G. Then you have to find I about XX and I about YY. This every class I cannot repeat. Okay, start. Location of centroid. Divide into part. Okay, start. I will take this as part 1, this as part 2. Here somewhere. Space problem is there. Okay, part 2. See, now this is 420. So centroid will be exactly here. G1. See, this is actually called flange. This is web. Actually, practically, these two will be equal. But here, sometimes question can be given when they are not equal. Then, see, 125 here. This is 400. Center of 400 is 200. So, this side, 125 plus another 16. 141. Oh, still this side. So, it will be, see, this gap is 125. If this gap is 125, if you want that side gap, 400 minus 125 minus 16, I wrote the gap that side if you want it. Okay, then see, centroid G2 is here. This is your G2. Okay, start. Now, location of centroid, usual statements you write. Consider axis OX and OY reference axis. X bar this way, Y bar this way. Remember, those who find difficulty, I will tell you, I should tell red color, part 3, lecture 55, where I told there is a limit for everything. I told there. I told at that time, there's a limit for everything. First of all, I should not write anything. I should mark centroid here and start moment of inertia. Still, I want complete question. So, write X bar, A1, X1, A2, X2. See, X1 is 400 by 2, X2, 125 plus half of 16, written here. Then Y bar here, Y1, 250 plus another 20 by 2. Or 270 minus 20 by 2 also will do. Y2 is 250 by 2. You get X bar, Y bar. So, till this step, see, till this step, if anybody expects more explanation, I will tell there is a limit for everything. That's all. Okay, now, right, go back, locate. X bar, 177, see, 125 plus 16. How much it is? 141, little more. But not up to here, because up to here is 200. So, it will be somewhere here. That much common sense required. YY. Extend further. See, here this way. Jump here. YY. See. This is your X bar. X bar equal to 177.667 millimeter. All dimensions. I told every class I won't waste time writing all dimensions millimeter. You write it. Okay, then from if it is not millimeter, I will tell you from this extreme end, then this distance will be, see, if you want from this YY axis, YY. Suppose you want from this extreme end, if you require, that distance is from 400 subtract 215 point, where is it? No, 215 point, it is something else. 222 point, I noted down there. 222.333. 333. Okay. Now, Y bar, how much? You got round number 215. See, this is 250. Center is 125. So, little above. Somewhat near to the junction here. See, exact scale are not possible. X axis. From here we got y bar equal to how much? 215. If this is 215 millimeter, from the top edge it will be from 270 minus 215, it will be 55. Okay, calculated value not given. This also is calculated value. Okay, over. Now location of centroid over. First of all, up to here, anything told means waste of time. Now important. Okay, now this all you write here. Location centroid over. Now next. Calculation of I about xx and I about yy. Okay, start. As usual, write by parallel axis theorem, I about any axis equal to usual. You should write it. Ig plus area into h square. H square. Okay. This question I will write. I about any axis. Next time I won't write it. I will put just a parallel axis over. What is Ig? What is area? What is h? Explained more than 100 times now. Okay, start. Now, first I about xx axis. I'll start here. I about xx. Sufficient space. Okay, I'll start here. I want more space. I about xx. Start. Come to figure 1. Come to centroid. Axis passing through centroid and parallel to x-axis. This axis. 400 into 20 cube by 12. 20 cube by 12 Ig plus area. 400 into 20 is the area into from centroid of that component to x axis, this distance square. See, from here to here, perpendicular square is 55 minus half of 20. 55 minus 20, the last number h square is the most important square. This will give I about xx for figure number 1, then plus for figure number 2. I about its own centroidal axis. 16 into 250 cube by 12. 250 cube divided by 12, Ig. Plus area. 16 into 250 is the area into from centroid to this axis. See, this distance square, that is 215 minus half of 250. Further explanation is not required, sufficient. It is over explanation. Those who are serious and studying everything, they will tell this is also not required. We can do ourselves only. Calculate the answer. Whatever you get, you write here. Equal to, write the answer preferably in 10 to the power 6 millimeter power 4. Answer not required. When everything is explained, okay, 1 minute. Answer you write in 10 to the power 6 millimeter power 4 is my way of writing. Okay, then I about yy. Now remember, about yy you want to start. Come to centroid. Axis passing through centroid parallel to yy is here. See, this axis. 20 into 400 cube by 12. This all explained earlier, plus area. 20 into 400, you can write. Some will tell, sir, there you wrote 400 by 20, rectangle. What way I write here? Usually same way I write here. Into, from centroid to yy axis, see, this distance square. That distance square, two options are there. One of the option is, see, this is 222.333. From here to here is 222.333, subtract half of 400. 222.333 minus 400 by 2 whole square over. One option. Other option is, see, this is centroid G. This is 400. This is 200, half of 400. So, from half of 400, subtract, see, from half of 400, from this distance, subtract x bar value. So, you can write 400 or, see, 400 by 2 minus 177.667. Anything will do. Okay, plus. Next. Okay, come here. We want about yy. First about its own centroidal axis. See here, this axis. It is 250 into 16 cube by 12. 250 into 16 cube by 12 Ig plus area. 250 into 16 is the area into from centroid here to this one, this distance square. That distance square is, see, 177.667 177 minus 125 minus 16 minus 125 again minus 16 by 2 whole square. Okay, that's all. Or you can do one more thing. If you look that side, it is, see, we want this distance square. That distance square, if you do that side, is 259. See, this is 259 from here to here. Then plus 16 by 2 will give this distance. 259 plus 16 by 2. Then subtract 222.333. Whatever way you can do, get the answer, preferably in 10 to the power 6 millimeter power 4. Question number 9 over. Now, to save the time, I will give question number 10. See, very easy question. 10. Same cross section, no change. The purpose is to understand. Sometimes I can change the question. Why I am not changing? Because it will save me writing. See. Oh, the very purpose is lost here. I should have maintained that one. Okay. No, then I will change the question. Then I will change it. Because I used same question to save the timing one. Okay, no problem. See, some other number. This is 200. This is 16. This thickness is 12. And this time, overall depth given of, say, 300. And this offset given. Some offset, how much, say, 200 by 2. Some 200 by 2 is 100. It's lesser, I want 50, 60. 60 means little bigger. 80 will do, 80. Question is, find moment of inertia about two axes they want. Which one? They will tell now. About OX and OY. See, they will mark a point here. See, this is 12. They will show where is OX and OY. They decided, see, this is not that point. That is very easy point. Okay. Here we will give. See, they projected here, mark the point O here. Then they are telling this is X, this is Y. Yes, that's the question. Okay, done. See now, solution. Start. First, make a note. All dimensions in millimeter, make a note. As usual, class like part 3, lecture 55 is always there. Make a note here. Moment of inertia required about OX and OY. This OX, OY are not centroidal axis. They are given axis. So, Therefore, this question, there is no need of locating centroid. Then therefore, directly start. That's all. Directly start, but before that, divide into parts. See here. 200. Somewhat to scale. This is 200. 200. This is 16. See, total depth is 300. And this is 80 plus 12, 92. If the centroid is here, for this one, if centroid is here by chance, see, if this centroid, suppose I call later this figure number 1. If this is centroid G1, this will be 100. 80 plus 12 is 92. So it will start somewhere here, see. This way, little more depth, 12. Okay. This thickness is 12 and total depth is 300. See, total 300 given. So this distance you have to calculate. From 300 subtract 16, 284. Rounded means calculated. Okay, then they also told, see, if I project here, this offset is 80. Then I'll put one thing, 12 I'll put here. I'll put 12 here. Then if you want this offset, if you want from 200 subtract 80 and 12, 92. So this is 108. Correct? 89 is correct. 108. Okay, this one. Now this I will take figure number 2 and this is your G2. G2 over. Start. Now directly start. No question of what? Locating centroid. Directly, right? First, as usual, statement right by, see, right here. Calculation of I about OX and I about OY. This is not XXYY. First, parallax theorem, write the statement. I about any axis equal to usual statement. Ig plus A into H square. Someone will tell not writing clearly. No, I won't write clearly. If anybody got complaint that not written correctly means you don't continue my class. So much explanation given. First, I about OX. Start here. I about the mark here, the two axes. Now red color. Why? Because when you find moment of inertia, I always want red color. Red color does not mean that it is centroidal axis. It is a required axis. See, this is O, this is Y. Okay, start first. I about OX. First about its own axis. 200 into 16 cube by 12. Q by 12 is Ig plus area. 200 into 16 is the area into from centroid to required axis perpendicular square. This square is 284 plus 16 by 2. 16 by 2 whole square. Or you can make a note here, or 300 minus 16 by 2. You write it here. Or you can tell 300 minus 16 by 2 whole square plus second one, I about its own axis. 12 into 284, 12 into 284 cube divided by 12 plus area. 12 into 284 is the area into from centroid to OX. This distance square is directly 284 by 2 over. Direct answer. I will not explain this one, not required. Okay, over. That's why the master question done earlier with all explanation, everything you study. Answer I'm not interested. I don't want to waste time on answer. Calculate. Okay, now I about OY. Whenever I write the full step, then unless that answer is required for next step, I will not write. See, when I locate centroid, I write the answer because centroid is required. Okay, now I about OY. Start. First, I about its own centroidal axis. 16 parallel to OY. 16 into 200 cube by 12. See, instead of OX, OY, they can call this ABCD also, whatever name they can give. It is 16 into 200 cube by 12 Ig plus area. 16 into 200 is the area into from centroid to this axis, this distance square, that is half of 200. 200 by 2 whole square over plus for this one we want I about OY. First about its own axis. See here, parallel to OY. 284 into 12 cube by 12. 284 into 12 cube by 12 is Ig plus area. 284 into 12 is the area into from centroid to this axis, this distance square is, see, from here to here is 12 by 2, 12 by 2 plus another 80 whole square over. Calculate, you get I about OY. Question 10 over. Next question 11. I will prepare and start. Okay. Now question number 11. See, now find moment of inertia about centroidal axis. 250 mm, 18 mm, 15 thickness, total 350. First class, make a note. This is very important because this is how the actual T section, steel rolled section will be there. See here, last time I have given this distance lesser, this distance more. So this web is slightly this side. In this question, see, you should write all this one. No data given. So it is understood that this web is exactly center, or the left side offset and right side offset are equal. You write here. That is understood that, see, this distance and this distance both are same. Understood. You write there. Both are same. Okay, now, therefore, write immediately. See, again, same story. We have to find I about centroidal axis. That is, you have to first locate G, then find IXX, IYY, you have to find. But to locate G, you should use symmetry. See here, given section, T section, make all this note first. This all told for you earlier. See, this is a given T section. First make this note. Correctly write. This is a given T section. Okay. This is correctly symmetrical about this axis. See, symmetrical. This is axis of symmetry, that is YY axis. So there is no need of X bar calculation. X bar not required. Or if this is 250 from the extreme end here, see, from here to here, or from here to here, both are 250 by 2 and 250 by 2. Understood? You make this note. Therefore, you have to locate, see, therefore, we have to locate only XX axis, for which you require, if you want to locate XX axis, you require Y bar. Okay, start. The statement all you write, Y bar. Y bar. Now, origin O, OX, OY not required, only Y bar required. Consider bottommost edge AB as reference. AB is our name. You consider the bottom edge, say AB as reference. Y bar equal to A1 Y1 A2 Y2 divided by A1 plus A2, write the formula, 250 by 16 into 334 plus 16 by 2, or 350 minus 16 by 2 plus 15 into 334 area into this distance. Divide by total area, you get y bar 244.691. Then locate 244.691 means, see, this is 334, it will be somewhere here. Exact scale is not required, x-axis. So, see, from here, this distance, oh, zigzag it has gone, okay, no problem. Those things all don't bother. See, freehand, sometimes it is not possible to write neatly. This is your y bar. Y bar equal to 244.691. Then, if you want from top to here, it will be 350 minus that one. I noted down 105.309. This is your x-axis. Okay, now y-axis directly mark here. See, your y here passes through centroid of both the parts. Y. Okay, over. Now everything is ready. Go for moment of inertia calculation. Okay, start. First Ixx. First write as usual. By parallel axis theorem, I about any axis equal to Ig plus A square. If you cannot write, I am helpless. Don't study anything from me. Suppose you feel, write that also. There is a limit. I about AB. Now do one thing. Mark AB once again. Hurry. Now AB is gone. AB is there. See, I about XX. I about XX equal to, start. See, I forgot to mark G1, G2 here. G1, G2 understood. People are knowing it. I about its own centroidal axis. See, this one. 250 into 16 cube by 12. 250 into 16 cube by 12, Ig, plus area. 250 into 16 is the area into I about xx we want. From centroid to xx, see, perpendicular square. Axis horizontal means distance vertical. From 105.309, 105.309, subtract half of 16. That square, okay, over. Ig over, etc. over, plus. Come here. I about its own centroidal axis. 15 into 334. 334 cube divided by 12 plus area. 15 into 334 is the area. Space problem is there. Into, I write here, space problem. Into, from centroid to this axis, this distance square is 244.691 minus half of 334 minus 334 by 2 whole square. Write horizontally, not this way. Okay, calculate, you get Ixx. Iyy. Now be careful. Centroid is here. First I about axis passing through centroid parallel to Iy. Oh, it is same axis. See, this axis. 16 into 250 cube by 12. 16 into 250 cube by 12 Ig plus area is 16 into 250 is the area into from centroid to Yy perpendicular square. Axis vertical means horizontal. No, your centroid, see, when you do I about xx, centroid is lying outside, centroid is lying outside. But when you do I about yy, both the centroids lie in the yy axis. So into 0 square. It's very important. See, 0 square. Okay. This is for first one. Plus second one. Come here. I about its own centroidal axis, same axis, 334 into 15 cube by 12. 334 into 15 cube by 12 Ig plus area. 334 into 15 is the area into, once again, see, from this centroid to yy, no, 0 square. You get I about yy. Calculate both. Question number 11 over. Now only I will do one more question. Okay, not sufficient. 11. 11 over. I forget the numbers. Question number 12 next. Next 12. Okay. See, first question. This offset was lesser. This offset more. Now I will make that offset more. But I will do one thing. To save the time, I will put inverted T now. See, I will go for inverted T. Just to save the time. Don't be wasting time. See, question is here. Okay, this way. This is some thickness here. This is 20 thickness. This is 18 thickness out of scale. This full width is 150. This is 200. And this distance is 75, 40. Okay, 40, this one. Oh, no, I want this side lesser. Oh, no. See, it becomes same as last time. No. Okay, now it is okay. Okay, this is how much I told? Anything. 150. 150 half is 150, half is 75, 80. Okay. I will first prepare the solution. Take next question. See, now this side is more, this side less. To save time, inverted. Later exercises, I will give plenty of questions for you. Find moment of inertia about centroidal axis. Okay, this question. Okay, start now. Note, you should write all these if you are interested. You have to find Ixx, Iyy. You have to locate centroid G. There is no symmetry here. Therefore, X bar, Y bar, both are required. This time, part 3, lecture 55, there is a limit for everything. So now you cannot locate centroid, means high time, stop studying. Okay, start. Take origin here, X, Y. See, you take any one as figure number 1. Okay, I will take this again here, this one. This is figure number 1. This is 2, your choice. Start. A1, X1, 8, I am not writing. 18 into 200 into, see, 1 minute, I forgot here. If this is 80, this offset is 150 minus 80 minus 18. Okay, then X bar from here. 18 into 200 into, see, its centroid is here, G1, into 80 plus 18 by 2 plus this centroid is, see, somewhere here. See, this is 80, 150 half is 75. See, it is here. Little this side. This is your G2. Okay. 150 into 20 into 150 by 2 divided by total area. Y bar from here. 18 into 200 into 20 plus 200 by 2 plus 150 into 20 by 2 divided by area. Now if you cannot do that one, I am helpless. Okay, now it is your problem. See, there is a limit for everything. X bar, Y bar, locate. X bar we got 82. See, 80 here, slightly more. See, very slightly more. But up to centroid of this one is what? 80 plus 9 is 89. Little this side. See, these all small things counts. See, here space problem is there. I will bring it as close as possible. Okay. This is your YY axis. Okay, no space right there. Okay, YY. From here to here is 82.636. Then from here it will be total 150, 67.364. Y bar you got, by chance, round number came 70. 20 plus another 50. So 200 somewhere here, see. 20 another 50. Okay, out of scale. XX axis. Now, see, this OY is all not required now. From here to here. Okay, let it be there. OY. This is your Y bar equal to 70. If that is 70, from the top edge, it will be how much? Total is 220, 150. It will be 150. Okay, start. This all clear. Now, start calculation of moment of inertia. Right, parallel axis theorem. That all statement you write yourself only. Start. I about XX. Start here. I about its own axis, centroid. See, instead of every time telling, if I tell I about its own axis, it means I about an axis passing to centroid of that component considered and parallel to the required axis. So I about its own axis is 18 into 200 cube by 12. 18 into 200 cube by 12 is IG plus area. 18 into 200 is the area into from centroid to XX. See, this from centroid to XX, this distance square is from 150 subtract half of, see, this is 200. From 150 subtract half of 200. 150 minus 200 by 2 whole square. Y means, I told how many times earlier, okay, plus. For this one, I about its own centroid of axis, parallel to XX. 150 into 20 cube by 12. 20 cube by 12 IG plus 150 into 20 is the area into from centroid here. See, centroid is not, that is, centroid is here. See, from centroid this component to XX axis, this distance square, that distance square is 70 minus half of 20. 70 minus 20 by 2 whole square. Okay, calculate the answer. IYY, answer not required. IYY. First, I about, see now, its own centroid of the axis parallel to YY. See here. Its own centroid of the axis here. 200 into 18 cube by 12. 200 into 18 cube divided by 12 plus 200 into 18 is the area into, be careful, from centroid to this axis, this, see, very small, this distance square. Two options for you. One of the option is, see, from centroid to, see, from this, start this side, from extreme edge, see, from extreme edge to this axis is 67.364. From 67.364, see, from here to axis subtract this distance, that is 52 plus half of 18. Subtract 52 and also subtract 18 by 2 whole square. Or if you do this side, see here, if you do this side, see, this centroid is here. Centroid is here. From centroid to this extreme edge is 80 plus half of 18. 80 plus 18 by 2. That is from here to centroid. From that distance, subtract 82.636. Anything will do. Okay. Plus, for this figure, first I about its own axis. 20 into 150 cube by 12. 20 into 150 cube by 12 IG plus area 20 into 150 is the area into from centroid to this axis is 82.636 minus, see, 82 from here to here is 82.636 minus half of 150. 82.636 minus 150 by 2 whole square. Or if you go that side, see, from here to this centroid is 150 by 2. From 150 by 2, subtract 67.364. That also will do that square. Get the answer. Question number next 13 over today's last question. 13. What I will do is I will change the question now. Okay. Single stretch I will do. No pausing required because question 13. Once again inverted T. Question 13. Simple question. Question 13. Sketch is given here. Inverted T only. One side lesser, one side more. That does not matter. Okay, 1 minute. That side earlier over. So this side, yes. This side more, that side lesser. Okay, okay. Same type of question, but number I will change. See, this way. 10, 16, total given. Total is 300. This width is 250. And this offset is 250 by 125, little more than 125, 150. Find moment of inertia about not center of the axis. See, one point they will give O here. Then they will tell you this is OX. See, they will put 10 here. This is 10. See, in the question given X and Y. Find I about OX and OY. Okay. Write the question first. First, you have to make a note. This actually is very, very easy because no locating centroid. Right, first make a note. Required to find what? Required to find I about OX and OY. Therefore, no need of locating centroid. X bar not required. Locating XX, YY also not required. What you do? Directly start. Happy. Directly start. See. This is how much? 300 given here. This is 16. So this rectangle is 284. 10 by 284. Okay. 10 by 284. This is, I will put later, 10 by 284. Then here, 150, more this side. And that side lesser. Okay. Lesser. Okay. This is the 16. Okay. Out of scale. Okay. Now, see. Now, this is 10. If you want this offset, anywhere you can write. This is given in the question as how much? 150. If that is 150, this offset will be 150 plus 10 is 160, 90. This is 90. Calculated value, not given, 90. Depth here. This depth. 300 given, so this is 284, this is 16. Total is 300. 284 is calculated. Okay, now important, see, your mark axis, divide into two parts. See, as usual, this I will take anyone. For a change, I will take this is component 1, this is component 2 for a change today. Why always that one? And this width is not marked here. This width also you have to mark. This width is 250. All dimensions in millimeter. I told all in millimeter. Now, they see, mark that axis. See, they told some point O here, O. Then they told this is your OX axis. See, space problem here. This is your OY axis. OY. They want I about OX and I about OY. Start as usual. By parallel axis theorem, I about any axis equal to IG plus A square. If you cannot write means don't write anything. Start. Therefore, I about OX equal to start. So, mark centroid. Centroid of G2. G2. This centroid is, see, this is 250, half is 125, somewhere here. G1. G1 here. Start. First, I about its own axis. 250 into 16 cube by 12. 250 into 16 cube by 12 is IG plus 250 into 16 is the area into from centroid here to this axis. See, I want to be I about OX axis. This is its own axis. This distance square is 16 by 2 square over. That's all. See, so easy. No struggling here. 16 by 2 whole square. That is for first one. Plus for second one. I about its own axis here. 10 into 284 cube. 284 cube divided by 250. Go that side. Okay. 84 cube divided by 12. IG plus 10 into 284 is the area into from centroid to this axis. This distance square is 284 by 2 whole square over. So easy, see, red color. Why? Distance square. 284 by 2 whole square. Don't forget the square. Calculate the answer. Then I about OY. Start. First, I about its own centroidal axis. See here. This axis. 16 into 250 cube by 12. IG plus area. 16 into 250 is the area into centroid to this axis. This distance square, you should be careful. See here. This centroid from here is 250 by 2. From here to OY is 150 plus 10. Oh no, this is 150. Where up to here is 150 plus 10. See here into 150 plus 10. See, 150 plus 10 is from here to here. Then subtract, I want this distance. Subtract half of 250. 250 by 2 whole square. Or you can do one thing. See, this is 250. So from here to here is 250 by 2. Both are okay. 250 by 2 from this distance, subtract this distance. See, we want from centroid to this axis. See, our axis is here. See correctly, where is the axis? Required axis is here. So we want this distance square. That is 250 by 2 minus this distance is 90. 90. See, 150 plus 10 is 160. 160 minus 125 is 160 minus 125 is 40, I think, 40. Okay, 250 by 2 is 160 minus 125 is 35. 35. See here, this is 125 minus 30 also is 35 only. Okay, then plus. So remember, we want what? From centroid here to this distance, this square. You either look this side or that side. Lastly, for this one, I about its own axis. 284 into 10 cube divided by 12 plus 284 into 10 is the area into from centroid to this axis, this distance square. Oh, this is very easy. This is 10, half of 10. 10 by 2 whole square, that's all. 10 by 2 whole square. Calculate, you get the moment of inertia. So question 13 over. Next class I will continue. Little I sections are there, channel sections are there, some trough sections are there, this type of sections are. Okay. And hollow rectangle will be there, see this way. Everything will come one by one in order. Plenty of questions. Okay, now correctly go through all the questions and understand. Okay, next class we will meet. Thank you.